Well, hi everybody. Today we're going to have a look at two of the very big players in the calculus world, specifically to do with taking the derivative or the gradient function. And they are the product rule and the quotient rule. And they are two of the true Academy Award winners in the whole industry of calculus, if you like. And guess who this is? Yes, that's you. You're a star, and we are going to shine together through this whole thing of product rule and quotient rule. Now, a word of warning, the calculus gets a little bit muddy. So we have to put ourselves into four-wheel drive algebra mode and be careful not to be an algebra hero. In other words, don't do too much in the one processing step, otherwise you can get off the track and drive into the ditch. Okay, so we don't want to do that. So be careful and we'll shine together. Okay, now for the product rule applies where you have two functions which are multiplied together, so they form a product. Okay, we're going to call them u and v. So u times v for you and me, and there is the rule. dy dx equals the u times dv dx plus the v times du dx, or as I affectionately say, it's left d right plus right d left, where the d right means the derivative of the right hand term and d left means the derivative of the left hand term. Okay, so d left d right plus right d left, and you will never forget. Now let's try a couple, and specifically we'll try number A. Now in number A, can you see two functions which are multiplied together? I mean functions of x. Yes, I know you could multiply them out. Yes, you could, because they're kind of like a quadratic expansion, except that they've got squares and cubes inside the brackets instead of linear x functions. However, you could multiply them out and you could do the derivatives then of the individual terms. However, sometimes it gets considerably more complicated than that, where this rule comes in really handy as a little extra spanner in your tool chest of calculus techniques. So we're going to say this is a product of two functions. Yes, indeed it is. And I'm going to call y equal to that whole thing, so that I've got something to hang my derivative off in terms of dy dx, so that I'm speaking proper coherent mathematical language. And I'm going to call u the first one. Yes, I am. And I'm going to call v the second one. It's just as simple as that. Now, therefore, the rule says that dy dx equals u dv dx plus v du dx. Yes, it does. No. So I've got to find du dx, and there it is. Now, do you agree with me there? Don't go to sleep. 2x squared plus 1, the derivative of that would be 4x. Yes, check. That's good, very good. Okay, what about dv dx? Have a look. Make up your mind, and then I'll reveal it, what I think it is. Come on, what's there? V is 5x cubed plus 16. What is dv dx? You got it? Okay, I think it's 15x squared. Good work, you got it. Okay, so now we're just going to plug and play, as they say. Okay, so there's u is 2x squared plus 1. dv dx is 15x squared plus v being 5x cubed plus 16 times du dx, which was 4x. Yes, everything looks good to me. Now, the question is, do we leave it like that? Do we trudge on through the four-wheel drive mud? Or what do we do? See, the thing is, in an exam setting, you've got to be very careful to what extent you further engage with an answer to a question once you've actually got the answer. Because if you further engage, and if you run into the ditch, e.g. get it wrong, by further engaging, then you have lost your answer mark. And that's very sad, because you shouldn't have to lose it. In this instance, I'm given no guidance about what form the answer should be in, which is generally what you will be given in the exam, if it's a complicated thing like this. So, in the absence of any further guidance, I probably will I can see that there's going to be an x to the fourth term coming out of that first term of the two terms that you see there on that line. So 2x squared plus 2x squared times 15x squared will get me 30x to the fourth, won't it? So I can see an x to the fourth term, and similarly I can see an x to the fourth term coming out of the second bracket there. 5x cubed times 4x will get me 20x to the fourth. So there's x to the fourth terms coming out of this. So my instinct tells me I need to drive ahead into the rainbow. We'll do a snail trail here and see what we get. Well, see now, look, see there's those two x to the fourth terms. Well, I'm going to get Mother Duck to collect her ducklings and get those like terms together. So I've got 50x to the fourth now, and yes, I've got an x squared term and x term. Now, I'm going to take out the x in common. I'm going to factorise this and see where it takes me. Now, the 64, I'm trying to look for coefficient terms in common, but there aren't any, because 64 is actually 2 to the 6th, isn't it? And 15 is only 5 times 3, and 50 is 5 times 5 times 2. So, oh, no, there's nothing in common. So I think that's it, guys. So let's box it. Very good. And we will see what the calculator did. If this is this kind of thing here, this screen here shows you what the calculator can do if you were dealing with a technology-enabled exam. And actually, the calculator is a very smart little beastie, isn't it? Because it just did the whole thing without any thought whatsoever to all the work we had to put into it. It's a smarty pants, isn't it? Well, that's good, because we've got it available to use in exam 2. By the way, that is an app, an iPad app you're looking at there. Don't be confused. It doesn't look exactly the same as your CAS handheld device, but that is an iPad app which does exactly the same thing. So we've put in the derivative by using the shortcut Shift down on your calculator, and for that matter, an antiderivative is Shift minus, what am I talking about? And the antiderivative is Shift plus, for that matter. So we put that in, and everything's good, and that's exactly what we got on the previous screen. So everything is looking pretty good. And buoyed with that confidence now, let's go for the next one, the second one. Well, okay, so what is U? Is it a product? Is it a product? Well, it is. Yes, I can see that it's two things multiplied together. So what are those two things? Product of two functions. Come on, you have a look and see what you think. You got it? Right. Well, I think that's U, and I think that's V. Okay? Do you agree with me? Is it plain to see? Does it fill you with glee? My oh me. Sorry, I can't help myself. There we are. So now we're going to do the whole process. U is going to be x cubed, and V is going to be 3x minus 5 to the fourth. And now we're going to work out what du dx is. Yes, now come on, have a quick look and see what you think du dx is, because there's a little bit of a stranger danger thing in that one. Come on, what do you think? Yes, but did you forget something? I'll show you. 4 times 3x minus 5 to the cube. But oh, what's that 3 doing there? Well, if you have a look at that, you'll see that that one has got some chain rule in it. Okay, that's the chain rule. Now, do you remember how the chain rule works? If you've got a function of x to the fourth, then I call the function of x blob to do the shortcut version, and therefore, if you've got blob to the fourth, then basically the derivative is 4 times blob to the 3 times d blob dx, okay? So that's basically the quick and easy way to remember it, okay? If you do use all the variable substitution with U and all that sort of stuff, that's the training wheels way, and you need to start off doing it that way before you get to the blob version and get confidence, okay? Alright, now, that line there gives me the derivative of V. Now, we haven't even started on the product rule yet, so let's just get into that before we all go crazy with all this preliminary activities. By the product rule, we've got dy dx equals u dv dx plus v du dx. In other words, it's left d right plus right d left. Okay, we on track? Okay, you still with me? Now you think about it. I've got all that set out logically above, and that's what you need to do. Please don't give us the gobbledygook version. It's just really hard to follow. It's kind of like the road to nowhere, and it really gives the poor old examiner a lot of grey hair trying to figure out if there's any marks in it. So what is it? It's u, which is x cubed, times dv dx, which is what I've got using the chain rule, and then I've got plus v, which was that thing to the fourth, and then I've got du dx, which is 3x squared. Now, do you notice how I set all that out above before I tried to put it into the product rule? If you just try and go gung-ho and stick all that into the product rule formula, and you're not experienced enough, or you're in an exam setting where you're a little bit stressed, guess what might happen to you? Yes, into the ditch you go. So don't do that. Be careful and be logical. Okay, there it is. Now, I'm just having a bit of a look at that. I've cleaned it up, but see, now what do we do now? That is the question. Well, we're not given any guidance as to what form the answer's supposed to be, which you usually would be in an exam setting, so that you have to fit your solution into that particular form, so there's no ambiguity. But look, in this instance, with no guidance, I can see there's a 3x minus 5 in brackets cubed in one term and to the fourth in the second term. That's crying out to me, please take me out as a common factor, and I think I'll oblige. And I can also see some other stuff that can also be taken out as a common factor in both terms, but we'll do that in a minute. One thing at a time. I don't want to be an algebra hero, you see. Okay, done that. Now, so, do you agree with what I've done? Have a look at it. Yes, 12x cubed left after the first 3x minus 5 all cubed was taken out of the first term, and then I've got 3x squared into just 3x minus 5 to the 1 as the second term in brackets. That's right, isn't it? Now I think we'll clean up what's in those brackets and see where that goes. Okay, have a quick look. Do you agree? Did I make a mistake? No, I don't think so. Now, I think I've got some cleaning up to do inside the bracket. 2x to the cube term. So let's do that. Snail trail away. And, yeah, very good. I can see some common factors in the brackets now. So what can you see? Well, I can see that in terms of the coefficient, 3 will go into each of them. And there's also an x squared term to take out, isn't there? So let's do that. See how easy it is when you just go one step at a time and put yourself in four-wheel drive algebra mode? You don't make a mistake because you have the confidence to know that you're being careful as you go. Now, I think that's the lot, isn't it? I can't see any more. We've factorised it to death. I think we can box it now. Yes, and you're a star. Let's nudge, nudge, wink, wink. We did it, didn't we? Now, over the next screen, I'm going to show you the calculator version, the CAS handheld version, if this was a technology-enabled exam. And typically for a 2-mark question, they would simply require you to state what would be the product rule expression and then do the answer for a 2-mark question, okay? That's what they would do. You must show working for a 2-mark question. Good heavens above, look at that. Clever little calculator. It did it all without any fuss at all. So, now, what I did there, I put the derivative expression in, just put it straight in, and hit the enter key, and I got that what's on the right-hand side. Now, for derivatives, you just do the shortcut, shift down, and for the antiderivatives, for that matter, you do shift up. So anyway, it did a beautiful job. Okay, next one. What's this? Oh, looks fairly beastly, doesn't it? Well, the first thing to notice is that f dashed of x term there, that's derivative notation, okay? If f of x, capital F of x is the original function, then f dashed of x is like df dx. Do you know what I mean? So that's not a problem. That shouldn't put us off our game. Now, next thing is we have to work out a strategy for solving this thing. Well, look, it's a product, isn't it? See, x to the minus 3 is multiplied by that second thing in brackets cubed. So can you see the u and can you see the v? I can see the u and the v. Yes, for you and me. So there it is. Now let's just do it. That's right, product of two functions. Easy as pie, pardon the pun. And where is the u and where, oh yeah, that's the u. It's x to the minus 3 and v is, yeah, it's 10x squared minus 5 all cubed. Now we're just going to go and do the whole thing now. We're going to work out what du dx is. Now did you get that right? Good. Now what about the next one? Now you better be careful. That's a chain rule arama, that one. Chain rule arama. So it's, what is it? It's 3, now 10x squared minus 5 is blob in my mind. So it's 3 times blob squared times dblob dx. Do you agree with me? Otherwise you better do the training wheels version and put u is equal to, or no, don't do u, that'll get you into all sorts of trouble. Call it 10x squared minus 5 can be a, because we're running out of letters to use at the end of the alphabet, okay? I think I did that all anyway. That's chain rule, yes. So there it is, yes, okay. V is a cubed, where a is 10x squared minus 5, and I've just gone through this, the whole thing there. dv dA is 3a squared, and dA dx is 20x. This is the training wheels version, which you need to do before you get confident with the blob version, okay? Now, okay, therefore dv dx is, yeah, that's what you do. You put the dv on the top, you move the dx over underneath to the right, and what do you fill in the gap? Yes, dA. There you go. And then you just plug and play. It's as easy as that. 3a squared, which was dv dA, wasn't it? Have a look. Yes. And times dA dx, which was 20x. Now we have to sub in what the a was, because otherwise that's not very good, because we made up that symbol just to help us out. And there it is. There is your dv dx. Nasty little beast, wasn't it? Now I think we just need to clean that up a little bit. It'll be 60x times, yeah, that thing squared. Okay, it looks ugly, but hey, it's given up without a fight because we did it correctly. Now we've just got to put our formula for the product rule down. Okay, we went to all that trouble just to get dv dx and du dx was pretty easy. Now we've got to do the product rule. Okay, df of dx is u dv dx plus v du dx, and let's plug and play, guys. There's u, there's dv dx, there's v, and there's du dx. Now, ooh, yuck, lots of algebra mud here. Well, let's just go one step at a time. Now, what would you like to take out? I think we clean it up first, will we? Let's clean it up. Yeah, that's good. That's good. That makes me feel a lot better. It's a bit less ugly. Now, look, I can see. Look for the common factors. We're not giving any guidance, so we need to just plug away and go for the common factors. There's lots of stuff there in common. So, let's see. I've got x to the minus 2. I took out x to the minus 2 from both terms. Now, don't be confused by taking out x to the minus thingies in common factors. Look, for example, you can see that x to the minus 4 from the second term is really x to the minus 2 times x to the minus 2, isn't it? So there is an x to the minus 2 in there. So that's what I did. I took it out as a common factor, and yeah, I took those two out. I could probably also have taken a 3 out of both terms because 3 goes into 60, but I'll do that later, okay? Don't want to do too much at once because I don't want to be an algebra hero here, do I? No, no. Okay, so is that right? Let's have a look. From the first term, all I've got left is 60. And from the second term, all I've got left is, that's right, 3x to the minus 2, because I took 2 of them out the front, and times 10x squared minus 5 to the 1. Good work. Now, okay, what are we going to do? We need to clean up what's inside that second bracket, don't we? Let's do that. Okay, now did you get that? 3 times 10 is 30, x to the minus 2 times x to the 2 is x to the 0, which is 1, so it just leaves 30 for that second term in the square bracket. and the third term in the square bracket is going to be plus 15, don't mess the signs up, times x to the minus 2. Now, some cleanup required in the square bracket. I can see Mother Duck needs to collect her number ducklings together. And what do we get? Oh, what have I done there? Goodness, got very fancy. I think I was a bit of an algebra hero there, excuse me. So it was really 30 plus 15x to the minus 2, and I've taken 15 out as a common factor to make sure I'm right, because I make mistakes too when I become an algebra hero and get too smart for my boots. Okay, that looks good, doesn't it? Okay. Now, what do we got now? Yeah, I've put the 15 out the front. That's really all I've done. Now, the question is, do we leave it there, or what on earth do we do with it? Well, look, we're not given any guidance, so I think I'll probably just... Look, that answer would be acceptable, guys, but I think I'm just going to be a little bit fancy and for the sake of having a bit more fun. It's not an exam, so let's just go with it and see where we like it to go to. I think I'm going to put the x to the minus 2s as x squareds on the denominator, and I can see a common factor in that first bracket. There's a 5 in common, and I think I can take that out because the whole thing is squared. I can take it out as a 5 squared term, if you know what I mean. Let's go over the screen for more excitement. Okay, here's what we got to. Now let's do that. Do you see what I just said? Okay, I'm going to put the x to the minus 2s as on the denominators, and I'm going to take that common factor out of the second bracket. Wow, look at that. Isn't that exciting? Oh, the algebra mud is no trouble to us today. Now, okay, now we're going to work out what 15 times 5 squared is. Well, look, 5 squared is 25. Now, come on, 15 times 25. You take 250 is 10 times. 125 is another 5. That'd get us, wouldn't that get us 375? Yes, yes. Ah, look, that looks excellent. Now, is there anything more we can do to that? I don't think so. I think it's time to box it. Box it. There's the box. Hello, Mr. Box. We're very happy to see you. And we're at our destination. Now, I think we're going to have a look at the calculator screen and see whether that's what the calculator got. Oh, yes. It's extremely cool. Yes, I agree with you, Mr. Computer. I do agree with you. Let's have a go at the calculator screen. Look at that. Clever little calculator. Look at that right-hand side. It's exactly what we got. Gee, that's good for our confidence, isn't it? See? Four-wheel drive algebra mode saved the day. There's the thing I entered with my shift minus and then put the expression in, hit the enter key, and then I got that. That's if you were able to use your calculator. So that's really easy as. So don't go doing things by hand if you're allowed to use the calculator. For a 2-mark question, you just have to state the product rule for each of those functions, state the product rule, and then put your answer in, and you've got your 2 marks. But for a technology-free exam, you have to go through the algebra mud. Okay, here we come with the second partner in our Academy Award-winning team for calculus derivative type techniques, and this is the quotient rule. Okay, this guy looks completely ridiculous. However, it works like a charm. So you've got, this is where you have 2 functions, and as a quotient, the u is divided by the v, both being functions of x, and of course v can't be 0, otherwise we're really up the creek here. So here it goes, dy dx equals v du dx minus u dv dx over v squared. Well, try and say that 3 times quickly, but I simplify it to bottom d top minus top d bottom over bottom squared. And in class I usually give it an Indian accent, but I won't offend any Indian people by doing that. It's bottom d top minus top d bottom over bottom squared, and it's fun to remember it like that, okay? Now, here's one. Well, that's a quotient, isn't it? Boy, if ever I saw one, that's a quotient. Something divided by something else, and they're both functions of x. So let's make the y equal to u over v, where u is the top one and v is the bottom one. Now we're going to get our derivatives. Du dx is, oh yes, that's just 1. That's nice and handy. And dv dx would be, yes, do you agree with that? Good. Now we're going to plug and play into our formula, okay? Bottom d top minus top d bottom over bottom squared, and we'll plug and play now. There's bottom, there's d top, minus top d bottom, that's d bottom, over bottom squared. Oh dear, it's a bit ghastly looking because that bottom thing is going to become a quartic, isn't it? Ooh, well, let's just try and think. This is more algebra mud. Well, look, let's look at the top term. Do I need to simplify that? Probably I do, because the first term is a quadratic and so is the second term, so there's probably going to be some like terms to collect. And we'll just see where it takes us. We'll follow our nose and we won't lose our cool. We just take one step at a time. The journey of 1,000 miles begins with a single step, as they say, Chinese proverb. And it's very true. Alright, so what's that? Look, that thing's a bit complicated by that second expression on the top in the bracket. Look, we can cancel those 4x's out. Goodbye 4x's. That makes our life a bit better. Now we probably need to get rid of that second bracket. And be careful, because there's a minus sign out the front. Snail trail away. Yeah, that's all right. I'm happy. So, Mother Duckling, come and collect your x squared ducks. Yes, that's good. And your 8 plus 1 ducks. Good. And I can't see anything more to do with that. I think that's box time. Ah, Mr. Box, how nice to see you. That's it, guys. We did it. And you are a star. You really are a star. It's so good to use four-wheel drive algebra mode and to follow the rules and to set it out logically. Okay? Okay, I think we're going to do the calculator version now and see what we get. Oh, look at that. Clever little calculator. It got exactly the same as we did, except it put a minus sign and a bracket on the top, on the numerator there. I don't know why it does that. It's one of the things to do with the way the calculator is programmed. Okay? Yes, we plugged that in, and yes, we plugged that in, and we got that thing. So, that was it. So I think we've just about got there with the product rule and the quotient rule. So, give yourself a pat on the back. Well done to you. And just remember, the answer is never very far away. Can you hear that little squirrel whispering that to you? The answer is never very far away. And another one for you. Inch by inch, anything's a cinch. Don't be overwhelmed by these things. Inch by inch, anything's a cinch, but mile by mile, life's a trial. So don't let it become a trial, okay? All right, thanks so much for listening, and we'll catch up with you next time. Bye for now.